Thank you very much, Mark, for the nice words, and a warm welcome from my side to everybody. Second day of an awesome conference. I hope everybody is also awake. I wasn't that much this morning. Okay, so today I'm going to talk a bit about alternative technologies to REST. So we want to have a look what's in the toolbox beside what we are so much used to see if for the next challenges that we have at hand, there might be valuable alternatives available. Just some warm-up questions. Can't hardly see you, but who of you is working with REST? Okay, who's not raising the hand is straight lying, I would say. Who's using service and events? Okay, a few. And how about WebSockets? Also a few, that's cool. So just a little side note, when I'm talking about REST today, I mean any kind of HTTP JSON APIs. I will not argue about using of HOS or what is real REST, what's not real REST. That is for this talk not really relevant. So what can you expect over the next 50 minutes? I would like to share some experiences that I made providing and consuming REST APIs and go a bit through the limitations that I've experienced over the time and introduce three alternative technologies there being GraphQL, gRPC, and RSocket. So we will do a broader look on the alternatives. What we won't do today is a structured comparison of performance things. We won't see any performance charts or no deep dive into any of those technologies. There are two more talks today which are really nice continuations of at least two of those technologies today. And we want to have a look definitely how they are implemented in Spring. So how the Springy way of implementing an API with these technologies look like. So when you get out here today, I hope you had a bit of fun, you learned something new, and you know what to look in deeper for your next API challenge at hand. So the first question is, why the heck might you actually look for an alternative API technology? So what challenges might you have that we cannot solve with the REST API that well? Well, first of all, without a doubt, REST is really cool in a lot of senses. It's widespread knowledge everywhere. It's supported in all the languages, frameworks that we love. You can use all the basic things from HTTP protocol, like caching, like so on and so forth. If you use hypermedia links, that's the only time I mentioned that, it's also cool because you can use it for transferring information about permissions, possible state changes, and so on and so forth. So quite a cool things. And with the rise of HTTP2, a few of the limitations that we had, limitations of concurrent connections from browser-based applications, has also got a lot less tricky to handle. And with service and events, you also get some kind of streaming semantics from the server streaming semantics as well. So let's take a look into a simple example that we are going to use to compare the different technologies. This is like the underlying domain model from a very simple task management solution. You have three contexts here. You can sign up users. You have like a context where you can manage the little org structure of a company, basically the customers here that are paying maybe. And then you have the core domain that where you can manage your projects and with tasks, assign them to users, and keep track of those. And I guess if you are going to build this with a current Spring stack and with REST, you may end up with a kind of an architecture like that. So we have three microservices maybe, all having a REST API bundled together with Spring Cloud Gateway. And then you might have different clients here, mobile apps, single-page applications, so web browser-based apps, or any third-party backends. So the REST API, especially for fetching data, the endpoints might look like that. So it should look very familiar to you. And just to take one resource out there, the one for manipulating tasks as well, to have mutating operations here as well, might look similar to that, just as an idea. So you can create tasks here, you can change their status with some action endpoints, and so on and so forth. And technology-wise, the underlying technology is also very well known. So we either have, when we work with Spring Web MVC, or WebFlux, and it offers us then the various endpoints. And we have basically the request-response principle communication pattern at hand that we can use. So now There might be a situation where this is not enough. So, for example, you might have clients with very different needs how to fetch that data, or the underlying data structure is far more complex than the simple example that we have here. So you have large, complex data structures that you would like to provide over that API, and the clients might need that portion or that portion of the data, and you don't know that, because you might even offer this as a product, the API as a product. Or you have an application where your clients have a high frequency of communication between your client and your server, and latency matters a lot. So there are various reasons where this basic set that we have with REST APIs is not ideal, and where we might look for something else. So the candidates we want to have a look into today are those three. GraphQL, which was originally founded by Facebook, is open source and has large support in the community, and as we see, is also now a first-class citizen in the Spring world with Spring GraphQL. So we will, for the examples, we have taken this new Spring GraphQL library here. gRPC, we have taken a library from the community here to compare this. And then we have a third one being RSocket, which is not that well known. It's a bit more niche, originally developed by Netflix. And it's also supported by the Spring framework natively, part of Spring messaging. And those three will now have a look into what they have on offer for us. So who of you has worked with GraphQL so far? Okay, a few. That's cool. I guess when you have worked with REST and you were in a situation where you had to fetch data for any kind of view of your clients, you may have ended up in a situation like that. So you had to collect data from different endpoints. You had to fetch it from, in this case, for example, fetch first the task list, and then get some identifiers out there referencing other resources. You had to go there, fetch the data, and so on. So you ended up with a cascading sequence of requests to be made, and that is slow and takes a while. So that's not ideal. And with REST, there is limited ways on how to approach this. The one option is you can obviously cut your resources differently if you are in full control of that, or if you are organized with teams that have maybe a backend for front-end approach where you have a small aggregation layer that is in control of your front-end team, for example. They can aggregate the data as they need on the backend side and then transport this to the client. Or if some public APIs also offer like some custom expansion mechanisms where they send query parameters like this here, where they basically say, okay, where you as a client can say, I'm interested in like a nested object, give me this in one go and expand the structure. But there's no standard way of doing this, and all the APIs that have implemented that are doing that slightly different. So let's see what GraphQL can offer us in this regard. Technically, GraphQL, if you're using the new Spring GraphQL library, is just another endpoint, a single endpoint where all the GraphQL requests are being received and handled. So HTTP is only used for transportation of your requests to the server, and you don't use the HTTP status codes, for example, anymore for reporting errors. And GraphQL is now a language that describes the payloads being sent over this to this single endpoint and how they are interpreted on the server side. Second, beside HTTP, you can use WebSocket for transport, for transportation of the requests, and that is also offered by default. And the good thing there is that it offers you, beside the request-response paradigm, it also provides you a request stream communication style, so you can make subscriptions to endpoints, and you get a constant stream of data back from the server, all with the same technology. So how does GraphQL look like or work like? The basic idea is that you have a schema, first of all, that describes the data that your API is exposing. So in this example here, you see that from the data model of our demo application here, the schema on the right-hand side shows you that there is a basic type called query, where we have two instances of. You can query for a list of projects. That's what's being meant here by saying, okay, projects, I get back a list of projects, and you can get a single project given by an identifier. And then the rest of the schema describes basically the content of the returned data. So the types here are representing the nodes of our data model, And this way, we have a full description of, first of all, the operations that the API offers, as well as the data that is being sent or returned. So with this, the client can send requests that look like this here. So you can make a request and specify exactly what you want to have from this graph-like data, and you exactly get what you have specified. And by doing this, you can, as a client, just transport the data that you really need for your use case. So the difference in the implementation later is that you don't implement really a fixed list of operations, but the server becomes kind of an executor for an arbitrary number of different queries that you can express with what you are exposing via that schema. So in this example here, this is like the Springy way of implementing this with the new Spring GraphQL library. You basically annotate a class, again, with the left annotation add controller. And then you have a set of new annotations to implement the so-called resolvers. So those methods that are, when a request is being made to the server, know how to fetch the different pieces of the schema. So the first one is here as at query mapping. That's, so to say, the entry point into your query. That's the method being executed if you send a query to fetch a single project in this case here, where you can hand over an argument. And then you have a set of more annotations like schema mapping or batch mapping that are explaining the server how to fetch the data that is part of the returned structure. So if the main object that we return is project and has a nested list of tasks here, or a nested list of participants, then the methods here, if you are requesting this, are executed that are annotated with the corresponding annotation. So schema mapping here means that this function called tasks is executed if you are asking for the nested list of tasks for a project. So let's have a look how this looks like before we do too much theory here. So we have here a little playground where we can play with exactly this API. So we do here a request for a single project, and so far I'm just interested in the identifier of the project and the name. And now I can go and say, I also want to have the tasks of that project, and of those tasks I'm interested in their names, the start date and the end date, and so on. And if you execute then this query here, you get exactly that response back, a customized response for the query that your client sent. Say again? Oh, sorry, I think this here is not really zooming in. That's really a shortcoming. So I will go back to the slides in a second, and then we can explain that further. So, this is the request here. And as mentioned, if this is being executed, these are the methods that are then being executed. So, besides queries, simple queries, you can also have subscriptions, which are then giving you a constant stream of data back from the server. And that is where you have to have a WebSocket connection open to your GraphQL server. And when this prerequisite is made, you can then also use the subscription mapping here, and then use the well-known Flux types here, like the well-known reactor types like Flux, to define a method that is giving you the stream of data back, and with this getting, in this case, a constant feed of updated project information as soon as something is happening. There's a very thin specification. There's a specification for like a very lightweight WebSocket wrapper. That is called GraphQL VS, that is wrapping the query when you send it over WebSocket, and this way you could transport it also via WebSockets, not only subscriptions, but any kind of requests. So I'm sorry if this is, again, a little bit too small, but just to show you this here, now this is connected via WebSocket here. If we subscribe for projects, we get here back a list of all the projects as a stream, and every item of the stream contains then the requested attributes of this query. And if I stay connected here and do an update in the application itself, so I go here to my list of projects and change, for example, like the start date of a project. then I get immediately the result back over that subscription mechanism. So this way I can very easily implement mechanisms to update my clients online with changed data. So although it's called a query language, it also supports mutations. So the third basic type that GraphQL offers is mutation, where you can specify the operations to change data. Here an example how you implement an operation to create a new project. There's a corresponding annotation for that you just put on a method, and that's all you need. And then you can start also creating data over this API. So there are a couple of scenarios conceivable where you can even use this in an existing application landscape. So, for example, you could replicate data from your other services and offer a GraphQL API as a public API if that becomes handy. You just have to be cautious here. You have to re-implement things like security and so on. Or you can use also GraphQL as kind of an entry point into your backend system, and then use the existing REST APIs to resolve the actual data. So this way, you replace maybe a gateway with a GraphQL API in front that collects then all the data from the different backend services. So a quick summary for GraphQL. It is made to address the problem of over or underfetching data so that it reduces the number of round trips when you are especially doing this last mile transport from your clients, so from your mobile clients or your browser-based application to the server, ideally to one for a use case. Schema introspection is also quite nice, as you have seen when I was playing around with Postman. When you, in a development environment, expose the schema, the tools are being able to read this and provide you all the code completion and so on to explore the API. And it's also nice to have like request-response pattern as well as request-stream pattern, which are, I think, nowadays, if you implement clients, the most often used or requested communication patterns. A few things to consider is you just use HTTP for transport, but the default caching for HTTP doesn't make so much sense here anymore. You're not using like HTTP status codes for error reporting. The error comes in the payload itself, so that is a bit of, you need to change the way you deal with this. And you need to be careful when it comes to graph sizes, because you can imagine that if your data model is quite large, that you can easily overload the server, so it makes sense to implement some limits or also some pagination mechanisms that you don't make requests that are ending up with like thousands of nodes being returned from the server. So that was GraphQL. Now the next one is gRPC. gRPC is was initially developed by Google as their internal successor of their RPC framework, and it's now open source and supported in a variety of languages, frameworks, and so on. When you want to use it with Spring, you have to use a Spring Boot starter from the community. So it's not part of the official, it's not an official Spring subproject, but it's a very well-maintained library, so it's really easy to use. The one thing that is sometimes problematic as well is that when you use REST APIs and you transport JSON data, that JSON payloads are not the most efficient way to transport your data, right? So it feels a little bit like you are moving and you are packing boxes, but you're putting lots of stuff in there that you actually don't need. And that makes the boxes like fuller, heavier, and you have to run more often and so on and so forth to have this analogy. Now, why is that the case? Well, JSON is a text-based protocol. And if you are serializing that to transport it over the wire, everything is text. A number is a text. Everything is being seen as text. And the second thing is that each time you transport the entire schema of your data together with the actual content. So all the attributes you transport, everything is actually, so to say, kind of waste that you don't need just to transfer the data. The second thing that's also sometimes a bit tricky, I felt at least, is that when you want to consume an API, depending on the tooling that you have, you may end up with writing some POJOs representing the payloads, like the data that you send there, the data that you get back. You have to use maybe or define some interfaces representing the HTTP endpoint you want to call, and so on and so forth. So if you have a tool stack in place, it all works fine. But let's see what gRPC can offer us to address those two things as well. So first of all, again, from a technology perspective, gRPC makes heavy use of the HTTP2 specification, which is compared to the previous to HTTP1 is having like a connection, the idea of a connection that is then using, or where all the requests are sent over a single connection by multiplexing. So HTTP2 has lots of frames defined, and gRPC makes use of those HTTP2 frames to implement all their different communication patterns. So if you use this gRPC Spring Boot starter, it spins off a Netty server, and the Netty server is then taking on those requests. So beside request response, you have lots of streaming scenarios that you can realize with gRPC 2. So you can make a request stream paradigm, so you get a server streaming, you get a stream back from the server. You can also send the stream from the client to the server, or you have a bidirectional streaming, so kind of a channel where you can communicate in both ways with streams. And that's all possible with gRPC as well. And to address the problem of like what I've initially mentioned with JSON, that you have this not ideal size of the payloads, gRPC makes use of protobuf to describe the data and to serialize and deserialize it. So you need to have, first of all, a protobuf schema which describes the service, the gRPC service that you're going to expose. So in this case here, we've just taken one service here out of this example. This is the task service offering a few methods to retrieve information of tasks or a list of tasks, and also to do mutations on those tasks. And the second thing is that all the data that you are sending there as input or output parameters, you also have to describe as protobuf messages here. So the right-hand side shows, for example, the payload that is being sent with a request to create a task. And as with other binary serialization protocols like Avro, for example, here they use a position number so that in the byte array that is later representing your payload, you know which position is actually which attribute, and this way you can leave a way to transport the actual schema with your payload again, and that makes this payload a lot smaller. The other thing which is quite nice when you have such a schema is that you can generate code out of it. So with protobuf, you also get like a Maven or Gradle plugin, and that generates code from that schema. And that code, in the language of your choice, here in this case, in our case, it's Java or Kotlin that you are generating there, you get so-called base classes. And these base classes you just have to then inherit from and implement the methods. And with this library, just from the server side, put in simple annotation on it at gRPC service, and that's fairly it, what you need to do to expose that service as a gRPC service over the wire. On the client side, it's also fairly simple, so you also make use of the generated classes here. So you have a stub, and you can inject it with this library here by defining a property wherever you need this and putting an annotation in front of it. And this annotation is referencing to some application properties to know where the physical endpoint is, where to go to. Other than that, you don't need much more. You can have blocking clients and non-blocking clients out of the box. The stubs for them are both generated when you are compiling, when you use the protobuf compiler. So this here is an example for the configuration in the application properties. The only mandatory thing really is the endpoint. You can put security information in there and so on and so forth. And here, this is using the task service, this client, in a non-blocking way. So you define basically a stream observer. This is the object that they use in the default gRPC implementation that comes with this library. But you can also plug in different implementations of gRPC in this library and get one that also works with reactor types, which is a little bit easier if you are coming from a reactor background, webflux, and so on and so forth. So where is gRPC good for? Well, gRPC is also a very good fit if you do service-to-service communication between your backend services. You can, for example, in our very simple scenario, fetch data from another service on demand, or you provide a streaming API if you want to replicate data to have it locally available. That's all possible. There is a limitation, because if you have, for example, browser-based applications as your primary client, then it's not such an ideal solution, since the browser, although they support HTTP2 for transportation, they don't offer a proper API to really have a low-level access to the HTTP2 frames and therewith implement the gRPC protocol. So the only way currently, if you by accident have already somewhere a gRPC service and you need to make it available to some browser-based applications, is by using a gRPC web project, which is setting up an envoy proxy for you and then translating this again into an HTTP JSON API. But I guess that's not the idea here for this talk, so that's just a fallback in case you have to. It's not probably the best choice in this scenario. So let's also have a look quickly here how this looks like. So we also have a little playground here. gRPC also offers inspection of your schemas, so you can also, like with GraphQL, provide the schema in a dev environment, and then tooling like those here can immediately offer you all the available services and methods on those services. Also generate you maybe a dummy payload. In this case here, we can subscribe to the tasks of a single project here, doing the same as we did with GraphQL. And now we retrieve the list of tasks for that current project here. And this is also an endpoint where you have subscription mechanism, meaning again that if we are, well, let me first clear this here. So if we stay connected here and do any change to a project, we are getting another updated item back. Sorry, this is like, no, that was wrong, because we have subscribed not to the list of projects, but to the list of tasks for that project. So I'm going in here and changing just a task in this project. Let's change the date here quickly, and then you get the updated task back. I was just a bit lazy, so there aren't so many attributes available on this endpoint. They are just missing implementation. And what you see here is the JSON representation of gRPC, so it also has a JSON representation that you can then use in those developer tools here in order to also being able to read the data when it has been deserialized. Yeah, and that's pretty much it. So summary, takeaways for gRPC. gRPC is really efficient thanks to protobuf. So if you have lots of traffic between backend services, it's really worth considering it because it brings really down the size of the messages being transported. You have a variety of different communication patterns, and it's also supported by Spring Cloud Gateway for routing, because at the end of the day, every gRPC service, which consists of the service name and the method name, like every method basically is represented by a route where you have the service name / the method name, and that you can use also for default HTTP routing to route then the request to the right implementing gRPC service as well. You need to learn a bit protobuf, and that sometimes feels a little bit strange. So if you want to, for example, create, let me go back here. I think there was an example in here. Yeah. So for example, here we have, this is like a command-based reschedule task. This is a command-based method, so you don't expect anything back, but you still have to define that it's an empty result, but there's a default empty message type. Those are the things that are a bit, that you need to get used to, that are a bit different to what you usually are used to, just saying void or something. Okay, so third one in this row, RSocket. So RSocket is, from my perspective, a very interesting protocol because it makes use of WebSockets or TCP for transportation. And if you have a browser-based applications and want to have bidirectional streams, the WebSocket API is ideal. But when you work with WebSockets, with plain WebSockets, it feels a bit like yeah, like having a highway but no car to drive on, so it's pretty naked. You have a good connection. You can send messages in both ways, but you need to either come up with a custom protocol on top of that to connect like the messages being sent and being received and so on. And there aren't so many default protocols available. Maybe some of you has worked with Stomp as a protocol on WebSocket. Have somebody worked with that? Yeah? But it has more kind of a broker mechanism, so you can subscribe to channels, and it's not ideal. It's not really reflecting all the communication pattern that we nowadays really use. So let's see what RSocket can do in this regard. So technically, if you use the Spring Boot starter for RSocket, you get the RSocket implementation of Java with it as a dependency, and you can use the RSocket implementation of Spring, which is part of Spring messaging. Technically, depending on whether you are exposing that just via a plain blank TCP port or via a WebSocket port, it can either hook into the Webflux server or it spins up an Netty server on its own for a simple TCP connection. So once the connection is established, you can send an initial frame, for example, to send a security authorization header. That's what we're doing in this example here. And then you have a speciality that's also different than with other technologies. So the term client and server is actually only, valid or comparable to used as in other scenarios for the handshake, for making that connection. So it just says that the one endpoint is allowed to connect to the other to open a connection. Once the connection is established, both ends can become requester and responder, so you can send requests in the sense with other technology call it a client. Here you can say requester to differentiate that. You can send then requests from both ends to the other end. And this way you can, for example, invert. Maybe for security reasons you are only allowed to connect in one way with firewall or whatever. You can then do this connection the one way, but actually making the request the other way, since this is then your application flow. So with RSocket, you have to remember the terms requester and responder as the two endpoints of the communication. You have real fire and forget semantics, since it's messaging. You can really implement that you send a message and you don't care that something is coming back and you don't receive anything, not even just an OK or something. It's real fire and forget semantics. You have the basic request-response communication pattern, and you also have some streaming patterns. And this is actually where the name RSocket comes from. So R in RSocket comes from reactive, so reactive streams. And RSocket, the purpose was to have a protocol that implements reactive semantics over the wire to allow you to have like back pressure working over the wire end-to-end from your clients to the server. And that works in a way that the RSocket protocol also defines lots of frames, so different byte frames that you send over the underlying connection. And there, in one of those frames, or in some of those frames, you can say, I give you now the permission to send me the next n items of a stream. And by defining the size of this n, the number of items that you are capable of processing, you can control how much data the one side, so either the client streaming data to the server or the other side, or both ways, how much data you want to get in one go. So, and similar to HTTP2, or to gRPC on HTTP2, here you have also the single connection and then this multiplexing so that you have any number of requests at the same time going over that single connection by multiplexing. And this is differentiated then by having a stream identifier, which is then separating the frames so that both ends know which of those frames that are sent over the wire belong to one logical communication that is currently ongoing. So here in this scenario, we have enriched this with another function. So we wanted to have like a chat room for projects where the members of a project can chat. So when we've used now RSocket to implement this, here in this scenario, again, you have a class that you annotate with @controller, and then there's a simple way to implement responders to received messages by using a well-known annotation message mapping. And then you can define a route similar to an HTTP route. That's also part of the RSocket specification that this particular message mapper is, or this particular function then reacts on. So if I send a message to the route project with a project ID and then chat, I get a stream of chat messages from that chat room back. And when I want to send a message to this chat room, I have another endpoint here that receives those chat messages. And yeah, this is then also available here in the demo. So works pretty nice with any kind of browser application. So assuming I write a colleague here, if she's also joining us, to come here to Spring I/O. I can send her a message. And this is now sent to the server via RSocket. And in this case, the React application here is also using an RSocket client to be connected to this chat room and then receive all the messages in both ways. You can do the same, or you can use this also, and that's why we have chosen an RSocket also for this demo here with this client. You can also use the same thing, for example, to online update your clients upon changes here. So if I make a change here, it's reflected on the other user's UI as well. And this way, it's very simple to have like a set of streams for the different information that you are interested in to be notified when the underlying data changes. So if you want to use this in a server-to-server communication, there's also in Spring very good support for the client side of that. So the main object that you need to work with is the RSocket requester, which is implementing the requesting side. You have a builder for that, and then you can make use of this requester to send messages to the different endpoints with a Fluent API like this here. So the upper one is sending a message, the other upper one is basically registering to the list of chat messages for a chat room, and the lower one here is the example for sending a message to the corresponding endpoint. So you can, for example, also use the RSocket API on top of like a new service, like a chat service that you put next to the other services to just have these streaming semantics, for example, as well. You can also maybe front some other existing services with an RSocket API to have a really lightweight transportation to your clients, being mobile apps or web apps. Thanks to WebSocket, it also works perfect with browser-based application. So this works also pretty well. Takeaways. So if you are looking for a protocol to be to work on top of WebSockets because your primary clients are browser-based, then that might be something for you. You have lots of communication patterns that you can use. There is one thing that you need to consider. The community around RSocket seems to be a little bit, I don't know, slow at the moment. So we need to see in the next months, years, let's see, months hopefully, how the community around RSocket will keep going, and if this is taking up or not so much. There's also a great idea out there called the RSocket broker, which is like a node in the middle, and then you can basically send the messages via broker nodes to endpoints and implement kind of transparent location, location transparency for the services that are implementing that. That was at some time part of this, or I was meant to be part of the Spring project as well. It's currently taken out, but we'll see. So it's also interesting. So if you are keen also to work there, maybe you can join the community and bring this forward, since I think it's a really great protocol as well. So now we have seen many choices, and now how do we make a decision? Well, first of all, there's nothing wrong with REST. And for many use cases, for our everyday life, it's probably still the best choice. So for many enterprise applications we are using, it might still be the best choice. But it's always good to know your alternatives. And if we have a look at the Google Trends, I took the screenshot this morning here, GraphQL is definitely, I think, the one that's most looked for, and also if you see how much traction this gains also in the Spring world, I guess this is something really worth considering. gRPC, I think, as well in certain scenarios. And RSocket, as I said, great protocol, but we need to see how this will continue going forward. The available communication patterns on those things here are comparable, with gRPC and RSocket obviously adding more. RSocket being also, or offering also this app-level flow control with the reactive semantics. And yeah, so I guess a few guidelines. So if you have, for example, an application with a really large, that's quite data-centric, and you have a large graph-like data objects that you want to expose over the API, or you might also offer this as a product, and you don't know where your clients, what your clients are, what kind of data they want to fetch in one go, GraphQL might actually be an option for you. So you can offer a very flexible API to your customers. If you are looking for something in a larger backend system for service-to-service communication, and you really care about, high throughput and bringing your payloads down, then gRPC might be a really good choice, thanks to protobuf. And as said here, if you're looking for something which is based on WebSockets, because maybe your browser, your primary clients are browser-based apps, then RSocket is definitely something to consider. By the way, I forgot to say that RSocket is also, you can also use RSocket with, for example, CBOR or with protobuf, so you're not bound to JSON there as well, to also gain the advantage of a good serialization, binary serialization format as well. So if you want to take a closer look into GraphQL, I can recommend the talk from Rossen at 12:30, or if you want to see another application where RSocket is being used, join Thomas and Mauricio at 11:30 with their talk. And all the examples can be found here on GitHub. So you can basically clone this repository. There are all the APIs there, the underlying services, the front end. If you need help with the example, feel free to contact me via LinkedIn, via mail, whatever, or let's talk later. I'm looking forward to discuss with you the alternatives that we have seen today. If you're looking for a new job, we have a really good office in Granada in Spain, and we have a large crowd here, so guys, say hello. So then take a shot of those QR codes, and let's definitely talk later as well. Thanks very much for listening. I hope you enjoyed that.